on CDs and DVDs lab. So the objective of this lab is to learn how to use a diffraction pattern to measure the pitch spacing of the data tracks on CDs and DVDs. And right now we're setting up the lab.
So what you'll need for this lab is a CD,
Laser pointer,
a DVD, a box,
protractor,
cardboard spacers,
and a blank index card.
tape, and a stand. Yeah, clamps and a stand. Okay, so we're gonna set up our lab now. We're gonna put the CD label down on the table. We're gonna put the box on top of the CD. We're gonna tape the index card to the box.
Notice how there's already cardboard spacers behind the protractor, so that there's a little bit of space between the card and the protractor.
And what we want is we want the 90-degree line to be about in the middle from the center of the CD to the outside. We're going to position it right about there. And we're going to have it so that this is perpendicular to the face of the CD, and this line is perpendicular, and this is
About halfway. Yeah, it
About-
lines
yeah,
up with
about
the diameter.
yeah.
So now we're gonna put the laser and everything on top of the box.
so that we can shine the light through the space between the protractor and the index card. And I'm just gonna reinforce this. Emily, please. And when we turn the laser on, and adjust it, we should get diffraction pattern. Ta-da! Oh, but
Make sure that
are we gonna do procedures
make
now?
sure that the diffraction that the laser pointer is pointing at
The center.
the center of the protractor, so you can get accurate readings
Where
when
the
you're doing
normal makes the CD.
Yeah.
And we're gonna have it at different angles.
And that is the setup for your lab. Yay! So for the next part of our lab, we're going to do 5 trials with a DVD instead of a CD.
Okay, now that we set up our CD lab, we have to get calculations and measurements. So we see that this is the incident ray, the light ray that's coming from the laser, and it's hitting the CD, and we see diffracted rays and a reflected ray. Now what we want to measure first is the angle of incidence, and how you do that is you measure the angle from the normal to the incident ray, and that would be theta I. And this light ray is reflected, so right here that would be the central maxima, m equals 0, and that distance, that angle from this ray to the normal would be approximately the same, theta I. And to the right of the central maxima would be m equals -1, m equals -2, m equals -3, and to the left, m equals 1, and so on, but we can't see it anymore. And what we would have to do is we would measure each angle from the normal to that angle, and it would be theta 1, theta -1, theta -2, theta -3, and then theta 1.
During the lab, we took pictures of all of our trials, 5 for the CD and 5 for the DVD, and also marked it on each of the index cards. These pictures shown are all of the data that we collected. After collecting our data, we recorded the angle values in a table for each of our trials for the CD in preparation for the calculations we would have to make. Then, we use a formula to calculate D, the data track spacing, which is equal to m times the wavelength divided by sine of the angle m minus sine of the angle of the incidence. We repeated this step multiple times for each of our trials and for each of the diffracted rays. Then, we found the average for each trial and then the overall average for all the trials to find an average value for the data track spacing of a CD. We were happy to see that our experimental value was pretty close to our actual one. After finding our experimental value, we compared it to the actual value. We calculated percent error by taking the actual value minus the experimental value and divided it by the calculator. Next, we repeated the process for our DVD trials and found average values for the DVD track spacing as well. We calculated percent error once more using the same process and found that our experimental value was relatively close to the actual value. Yay! After completing this lab, we learned how to use the diffraction pattern to measure the spacing of data tracks on CDs and DVDs. From our average values, we found that the data spacing on our CD was twice as much as that of our DVDs. We realized that because DVDs can hold anywhere from 7 to 25 times the amount of data on the CD, the DVD would have less spacing tracks to accommodate holding more data. As a result, the DVD would have less diffraction rays, as evident from the data we collected during the experiment.